Okay, so it should be recording. We'll get started. So like I just mentioned, we're going to talk about strings, loops, and if statements. We're also going to touch on building your own functions a little bit later towards the end. But before I jump into this, I just wanted to mention two other really important functions. I generated some examples here. Find interval. This is if you're trying to match, if sometimes matching doesn't work because you have to get the exact day or time or spatial position correct. Find interval lets you match within an interval instead of like an exact point. So this is really, really helpful. I'll send you guys this, or I'll put it in that folder. And maybe I'll just write a bunch of comments so you guys can kind of read along, because they're pretty specific, but they're super, super helpful if you run to a situation where you need this. So find interval, and then RLE, run length evaluator. So if you have some sort of political regime or hot hand stuff, like hot hand fallacy stuff, if you're doing that sort of research, you have like, Republicans for a few years and Democrats for a few years or whatever. The RLE function will kind of collapse that down and tell you how long each run was and who had the run. So they're pretty helpful. But anyway, so let's get started on strings. So strings are just character data. People use them pretty interchangeably. I think they're the same exact thing, but there are a bunch of really important functions that you need to know when you're working with strings. For web scraping, obviously, it's mostly strings because you're dealing with URLs, or you're dealing with other sorts of nodes and stuff like this, which we'll talk about. But the first one to know is paste. So I think we had used it briefly when we're talking about matching. What paste does is it takes two string elements and puts them together. So you can think of it like addition. Actually, in fact, I think in Python, you do use addition to do paste. In R, you have a function called paste. So if I paste Tom and York, it'll give me Tom York. Now notice something that's really important here is that Tom and York, neither of these have a space between them. The default separator for paste is a space. But if I don't want that space, and instead, like I'm making a URL, I want the default separator to be a dash. So now Tom York has a dash between his name instead of the space. So paste has the separator option that you can kind of toy with. If you use paste 0, this is a shortcut to say separator equals quote quote, which means like nothing. So it's a blank separator. So that output just looks like Tom York. In my mind, this is what I would expect the output to look like. If I'm pasting two strings without a space in between, I don't want it to automatically put a space there for me. So I always use paste 0. Occasionally I use paste, but almost always paste 0. Now, again, we're obviously not just going to be pasting two strings. We're going to be pasting vectors of strings. So if I have a vector, Tom and Johnny, and then I have this underscore. So 2 elements, 1 element, and then 2 elements. So Tom and Johnny, and then York and Greenwood. If I look at this, it'll do Tom underscore York, Johnny underscore Greenwood. So I'm able to make this happen twice based on the length of this one. So if you do one thing 4 times and one thing 2 times, it'll kind of recycle itself so that it will be the same length if you're pasting. So that's paste. Paste is just combining stuff. So if you have a bunch of URLs and then you have a bunch of like dates, you can just paste those two things together to make a new URL or something like this, like pages or something like this. So this substr is substring. So for substring, you will take your whatever string or vector of strings, and you will tell it what positions you want. So start at 1, end at 4. So this will look like THOM. Now, so if you have a vector of this, you'll have the start and stop for each one. Rania, did you have a question?
Sorry. Before we move to the next point, how about if I have, let's say, a whole column with names, 2 columns, and I want to do the same thing as you did for Tom, Johnny, York, Greenwood. How do I do? Because it will be daunting to type everything.
Yeah. So check this out. So we have our roster still, right? Roster looks like this. Suppose I want to have player, and then I want to put like parentheses number 0, number 31, right? So I can do paste 0 roster player, and then I'm using paste 0, so there's gonna be no space right after the like Kadeem Allen. It's gonna end right at the end of the end. So I want to add a space here, and then do parenthesis number equals, and I'm adding an extra space here, so there'll be a space between that and the number. And then I'll do roster number. And if I do it like this, I got it pretty much, except I didn't close the parenthesis. So if I want to close the parenthesis, just like this. Make sense? And then if you, go ahead. Okay. So this is an example of like a longer one where you might see a bunch of strings. So substring again is you tell it what string you want to subset or substring, and then the start and the end. So oftentimes you don't really want to do just like the first and last. So we'll talk about this in a second. Usually you want to start at the first character and end at whenever you see a space or something like that, right? You want to get the whole first name or something. So we'll talk about that in one moment. Let's talk about gsub. So what gsub does is it substitutes. So it finds and replaces. So if I want to remove all the O's in my vector radio head with an underscore, I'll use gsub and it gets rid of all the O's. If you want to get rid of just the first one, so just the first O, you would use sub, not gsub. Gsub is like general substitution. I think it's general. That's what it is in my brain. Now, grepl is going to give you a true or false value. Can it find this element or this character within this character string? So for example, it can find an M in Tom York, but it cannot find it in Johnny Greenwood. So true or false. And then I'm going to ask, can you find a Y in Tom York and Johnny Greenwood? And it better say true for both. It does. Okay, so now reg expr, I call it just regular expression. What this does is it tells you the position of whatever character. If it can't find it, so for example, M should give me 4 for Tom York, right? But for Johnny Greenwood, it can't find it. So what it's going to do instead is give me a -1. So you're able to kind of use grepl and regular expression kind of interchangeably, as long as regular expression is greater than 0. So for example, this first one, it gives you a bunch of stuff, but all you really care about is this first one. So 4 and -1. And then it asks, can I find Y in Tom York and Johnny Greenwood? And it will say 6 and 5. It can find both. And the position. Now, if there's multiple Ys, like if it was like Johnny Greenwoody or something, it would only identify the first one. It wouldn't say both. So that's just something to note. Okay, now let's say I wanted to kind of de-string this whole thing, right? If I wanted, I know at the space, I want to make like the break between first name and last name. So let me just save this vector. Radiohead. If I wanted to split it up between first and last name, I can use string split. And I would say Radiohead. And then I want to split it by this. So what this generates, it generates a list, which is the same length as your vector. So a list of 2. And each element in the list is the broken down version of whatever. So for example, if I added another one here that said Alex, there's no space here. So if I string split it, it's going to have Tom York, Johnny Greenwood, and Alex. So in order to get this to kind of be more amenable with like a data set, you'd want to use unlist. And that just makes everything a vector. So now this
And
is one
then
vector.
could you assign the output of that to a column in an existing data frame if you wanted to?
Yep. So let's say my data set is, so this is a data frame. Full name equals this. Right. So now Radiohead is a data set of one column. Now let's pretend Alex does not exist in Radiohead, or he doesn't exist in Radiohead. But let's suppose he's on that vector. So if I do this, I have Tom York, Johnny Greenwood. So if I try to append this, so if I say Radiohead first name, I couldn't just use this, right? Because this has 4 elements. This only has 2 rows. So this wouldn't work. So can someone think of an idea of how I can make this work? How can I get just the first names?
Could you index the unlist function?
Yeah. Yes. So what indices would I use?
We're looking at first name, so it'd be 1 and 3.
Right. So 1 and 3. That'll give me Tom and Johnny, and that works. Now, let's suppose I have a data set that's much longer than this. And I don't want to have to type out just 1, 3, 5, 7, right? I can do the sequence thing that we talked about in the very beginning where you skip by every other. But a really nice shortcut here is just put false and true. So this will just alternate and it'll pick every other one. So if I do this is for the last name, it'll just pick every other. So while the 1 and 3 is right, and that's probably what I would do in this situation, if you have a data set of 4,000 names, you might want to do just false true, and then for this one, you would do true false. Let's make this last name. It's not Radiohead, looks like this. Okay. So now, let's say I don't want to string split it. Let's say I want to do what I was saying before, where I want to use substring to just take the first names, right? So one thing I can do is I can say, okay, I want to take the substring of Radiohead full name, and I want to start at the first character, because that's like the first letter of their name. But I want to go until I find a space. So until I find a space, in other words, the position of the first space is going to be this regular expression, right? So instead of doing regular expression and looking for an M, I'm going to look for a space. So this is telling me to go from 1 until 8, 10, and 11. Why is it? Oh, Radiohead full name. So 5 and 6. If I look at this, I have Tom space and then Johnny space. So substring is inclusive. So instead of doing this, you want to do -1, right? Because I just doing it with regular expression gave me including the space. If I want to get rid of the space, do it this way. So you can either use the string split, you can use substring. In fact, you can even use gsub, which we'll show in a second. So this is going to be really helpful. This strategy is going to be really helpful once you're working with URLs and stuff, where you want to go from, if every URL is a different city, you want to go from the start of the city to use some other next character, and you want to be able to extract the city. Okay, so those are like the most simple uses of those functions, of these functions up here. Now we're going to get a little bit more into the kind of nitty gritty, a little bit more advanced string manipulation stuff. So if you want to find M in Tom York, you just put grepl quote M comma Tom York, right? In this case, instead of putting just M, if you put this vertical bar, it's saying look for A or B. So can you find A or B in this, right? If this was grepl. If it's G sub, it's saying replace A or B with nothing, meaning delete A or B. So if we show this output, it deletes all the A's, deletes all the B's, doesn't touch this one at all, deletes A, B, and then deletes all of this one. So if you can also do this same code, you can do this. You can also do delete all the A's, and then around this, you can get rid of the B's, replace them with nothing. So you can kind of nest the functions too. But I think this is much easier, especially if you have multiple things that you want to remove. So if you want to remove A, B, maybe D, and C, something like that. So you can keep adding to that list with the OR operator. Okay. However, what if you want to only remove the A's and the B's that happen at the beginning or the end, right? You only want to remove those sorts of things. For example, suppose you want to get rid of, like, if you have a field that's like a bunch of names and you want to get rid of like Mr. or Mrs., right? You want to delete MR, but you don't want to delete an MR that's in the middle of the name. You only want to delete it if it comes at the very beginning. So what you can do is you can use this little caret or this little $sign. What the $sign does says at the end, this A has to be the end of the string. So like something .com, if com or whatever happens in the middle of the string, you don't want to delete it. That's part of the URL. But if you want to delete .com at the end of the string, you put this $sign. Similarly, if you want at the beginning of the string, like www, maybe they have some weird API key in the middle of the string that has www just by chance. You don't want to delete that. You only want to delete at the beginning. So this A is going to be the end. This is going to be at the beginning. So we run this, we get Apple. Apple stays, or maybe I should just look at here. Apple stays because the A has to be at the end for it to get deleted. So this A gets to stay. Now, banana, the B gets deleted because it comes at the beginning, and the A gets deleted because it comes at the end. But the rest of the A's stay put. Same thing with beef, right? Same story as banana. And then Nokia, the A is at the end there. You can also do more general matching. Like instead of A and B, you can delete digits. So that's going to be for numbers. If you want to delete digits, you can do digit at the end, digit at the beginning, all sorts of stuff. Letters, spaces, and punctuation. So all sorts of stuff. Okay. Some of these, though, sometimes $signs appear in our data, right? And we want to delete them. So you would use gsub. However, I just told you that $sign is a special character. So if it's a special character, what I'm actually telling R to do, I'm saying find nothing at the end of the string and delete it. So delete nothing, right? Only if it comes at the end. So that doesn't make sense. So that's why this $sign here doesn't change. And this $sign here doesn't change. So in order to escape special characters, this is true for $sign, this is true for the caret, this is true for all sorts of other things like parentheses. You have to escape it with 2 backslashes. So now I'm hunting for the actual character itself, $sign. not the like meaning of $, which is which means the end of the string. So this gets rid of that. Is there any questions so far? The string matching takes a lot of practice, but it's really, really helpful when you have text data. Okay. So even more generally, we can start doing stuff where we just use a period, which is also a special character you have to escape using the 2 backslashes. Star, you have to escape it, and plus you have to escape. So what the plus means is it says it has to match the string coming right before it has to match at least once. So for example, what this is saying is it's saying delete a space and then if there's multiple spaces in a row, delete all of those extra spaces in a row. But once you see a new character, then stop. So for example, in this one, it matches here, but I'm replacing the space and then more spaces with 1 space. So this space is just going to get, this 1 space is going to get replaced with 1 space. This one here, where it's multiple spaces, like 2 or 3, that's going to get replaced with 1 space. This 1 space is going to get replaced with 1 space. This 1 space is going to get replaced with 1 space. And this 1,000,000 spaces is going to get replaced with 1 space. So if we show the output here, you're still going to have that 1 space in the beginning, but all the double spaces and further are gone. So this happens all the time, especially when you're getting data from the internet, like people hit spacebar more than once, or the code just has a bunch of spaces in it because of how they're going to structure it. Especially if you're scraping code, you'll, like we were talking about Python before, Python always has all these extra spaces. If you want to remove all of those, you can this way. Okay. So another even more general one, let's just talk about this for a second. So if I want to remove, I have this data set of Alex, John Cardazzi, Jeremy, William, Barbara, Nate, Crawford, Moon, Jordan, Scott, Elam, and then Julius Randall. So I have all these names. Some of them have middle names. I want to delete the middle names. So we can do substring, right, where we take the first names and then we take the last names and then we paste them together, right? So you find the first space until, or the first character until the first space, and you take the space until the last character, right? You can do it this way and paste them, but this is a little bit more elegant of a solution. So what I'm looking for here is I'm looking for a space followed by this plus, this dot. This dot means literally anything, just any sort of character. If I find a space, anything, and then anything plus means anything continued until another space. So essentially what I'm looking for are patterns that look like this: space, John, space. And I'm replacing space, John, space, or space, anything, space, with a space. So that'll effectively delete the middle names of each one of within each one of them, no matter how long, no matter what it says or anything like that. If it's numbers, punctuation, anything. That makes sense? Probably feels a little crazy to try to digest all of it at once, but we'll practice. Okay, so 2 more, and then we'll be done with strings. So this next one is saying we have to match A, B. So A is going to get deleted, and then B has to match at least once, right? That's what the plus means. It has to match at least once. So abs, this is found here in abs because AB is found right here. This one is not found, so this should not get touched. This one is not found, should not get touched. This one is found right here, lower abs, right? So we show this. We're left with the S. We're left with back, arms, and then lower S. Now what this star does is it says it has to match 0 times, at least 0 times. So in other words, it'll delete A or it'll delete AB. Because, for example, in abs, it matches AB. Great, it's out of there. This one, it matches the A, and then the B, it says, if you find the B, delete it too. But if you don't find the B, just delete the A. So for that output, it deletes the A. Same thing with arms, and then lower S is the same. So this is a little bit more greedy of a deleting or a cleaning function. So this little character is a little bit more aggressive than the plus. So plus is probably the one you want to use. It's really hard for me to think of a way to do this. For example, just to be safe about it, I would probably write this like this, where it has to read this, which I know will give me this, or A. This will give me the same exact result. So if you're going to do that, I think this is probably a safer, better option. Any questions on strings? There's all sorts of practice at the end. Okay. So now we'll talk about loops. So I have for loop here, but we're going to talk about for loop and a while loop. So the point of computers is to do things that humans don't like to do over and over and over again, right? Or things that we are bad at because we make mistakes. So what loops do is it takes a piece of code and executes it over and over and over again. You can either specify how many times you want to execute, or you want to execute until some condition is met. Or maybe you want it to iterate over and over again, but just slightly differently, changing one thing. Maybe you want to run a regression where you are only looking at data from 2004. Then you run the regression again with data from 2005, 2006, 2007, 2008. You can write a loop instead of having to write that code 20 times. So for example, if I want to print hello world 4 times, I write a for loop and I say for I in 1 to 4, this is my little index variable. So the first time it enters this loop, I is equal to 1. It prints hello world and says, okay, I'm done. I've reached the curly bracket. I'm going to go back up. I'm going to add 1 to I, or just pick the next element in the sequence. In the sequence, it's 1, 2, 3, 4. But you can put any sequence here. It'll print hello world again, and then go through until it hits 4. So this will execute 4 times. You can also incorporate the index variable into your loop. You don't have to do this. People feel the need that they have to do this sometimes, and you don't have to. It's just a possibility if you want to. So for example, if I wanted to say hi to specific people, like if I wanted to say hi, Alex, or hello, Brad, hello, Brian, hello, Adam, what I can do is I can just say for name in names, right? Names is this. Each time through the loop, names is going to go to the next element in the list. So this is not 1 to 4. It's just the actual names themselves. If I wanted to do 1 to 4, I could put a square bracket next to names, and then names 1, which is Alex, names 2, which is Brad, names 3, which is Brian, so on. So if I run this code, I'm using the paste function. I'm pasting this looping thing right in there, and it goes to each one. So if you're thinking about web scraping, I'm going to try to keep forcing you guys to think about it. When you have 100 websites you want to visit, or 100 links you want to visit, you're going to write the code one time and loop over all the 100 links, right? You're not going to write 100 different, 100 different pieces of code. So this is kind of what this is trying to gear to. So you're going to have to use some sort of paste function because you're going to be changing the URL for each one of these things. Okay, so I was just saying how this one will run for each name in names. This one will run for each I in 1 to 4, right? But sometimes we don't actually want, we don't know how many times we want it to run. Sometimes we don't know how many iterations that we need or something like this. So you could think about this in terms of like a convergence, right? If you're running some sort of code that you want something to converge, you want it to converge, you want it to run until epsilon is less than 0.01, something like this. Right, so you want to loop it, loop it, loop it, keep running until you get to this condition. You wouldn't be able to say like run 1,000 times because I know by 1,000 you'll converge. That might not be the case. It might be longer, it might be shorter. So in this case, when you don't know how many before you're running the loop, how many iterations through, use a while loop. So this while loop is called an infinite loop because I'm setting I to be equal to 0. And I'm saying as long as I is less than 2, keep printing hello. So this will literally run forever until your computer dies because I is never changing. So if we wanted to do this where we kind of ran like a while loop in practice, here would be an example. I set I equal to 0. I set iters equal to 0. I say, I'm going to set this seed. So I think I talked about this before. It's just so you can replicate randomness. And I'm going to say, as long as I is less than 1.96, keep doing whatever's inside this loop. So I is 0. So for the first time, it's certainly below 1.96. So what it's going to do is it's going to create a random normal number, just one of them. It's going to increase the iterations by 1. So I have 0, now it's going to equal 1. And it's going to print this paste. So it's going to paste iters, colon, and then it's going to round off my test thing. So if I show the output, when I ran this, it took 37 times before it was greater than 1.96. So you can see the first round, it was negative 1.253. So does not meet the condition, so it keeps going, or does meet the condition, so it keeps going. This one, same story, right? All the way down to this one, all of a sudden it's 2.84. That is bigger than 1.96, so we can break the loop. So another thing I want to show is that printing like this is a little bit annoying. You would never really, there's no really need to print like this. But if you're running this big long scraping code that's scraping, 40,000 URLs, you might want to know like what % done you are or something like that. So if you are interested in this, if I run this code, it's going to print all 37, right? If I slow it down, so I'll just do system.sleep 0.2. This will make it run, it'll make it wait 0.2 seconds. So you can see like this is what scraping would look like, where it just slowly outputting, right? So instead of printing and making a new line each time and then your console's like flooded, you can use, instead of print, use cat, use \r, which is like a new register. So it pretty much deletes the last line and fills it in with the new one. So for example, if I run this, it's more like a loading bar. See how it doesn't jump, but it keeps changing here. So just in the future, if you're ever looking for, if you ever have some long loop that you're running or something, this is a much better way to run it than the print, because print can get really ugly and this is really clean. Any questions on this so far? For loop, while loop? Okay. I'll keep moving. If statements. So now you want to have your computer make decisions on its own, right? You want to say, if some condition is met, if I find, like, for example, while this is happening, it's just going to do the same thing no matter what. But if I say, if it's less than 0, so if it's a negative number, do one thing. If it's a positive number, do another thing. I can have the computer make this decision. So for example, I'm going to use the names again. So for name and names, if the first letter, right, so substring name 1, 1, if that equals B, print nice to meet you. So for example, if I run this, nice to meet you, Brad, nice to meet you, Brian, it's not going to do anything for Alex and Adam, because this asks, does the first letter in Alex equal B? No. Then it just skips this entire if chunk and goes to the end and says, okay, I'm ready for the next round now. So it jumps back up. So for Alex and Adam, it'll not do anything. So if I wanted to do something for Alex and Adam, I would say if, write the code that generates, that's triggered. And then else, meaning for every other case, do this. So the output will be, hi, Alex, nice to meet you, Brad, nice to meet you, Brian, hi, Adam. So you can also do multiple if statements. Maybe you have 3 conditions. If it's less than -2, between -2 and +2, and then greater than 2, maybe you want to do something like that, right? So if the substring, if the first one equals B, for nice to meet you. Otherwise, if the name equals Adam, say hi Adam. But if all other cases, say bye whatever. And then every time, always print this.
So Alex, why do we have 1,1 after name?
So this is substring.
Yes, but
So
why
it's-
is 1,1?
This is saying start at the first position of name and also end at the first position. So that's giving you the first letter. So the result of this loop will be by Alex, because that's triggered in the else, right? Because the first letter of my name doesn't start with B, and my name is not Adam. So it just said by Alex. And then it says, okay, I'm going to go to meet the next person now because it hit this. Then it says, nice to meet you, Brad. Okay, I'm going to the next person now. And then it says, nice to meet you, Brian. Go to the next person now. And then it says, hi, Adam. And then I'm going to the next person. So you might have to structure this based on exactly how you want it. And you can realize that you can just skip me completely if you deleted this else, right? You don't have to have an else. You don't have to have some trigger for everybody, right? You can just delete this and then it'll never say anything to me. But you just have to realize that once you jump into this if, right? So for all the B's, it'll trigger this and then it'll jump all the way down. So if you have any sort of code that you need to run that's in here or in here, it won't do it. It's very much like a tree. It just picks one of them and then it skips the rest. So if you have some sort of code that you want everybody to, or every case to experience, then that's going to have to be put out of the if statement. Any questions on if or the loops so far? Is anybody lost? You can say it. It's totally okay. I would definitely be lost. This is a lot of code. Okay, then we'll keep going.
Well, quick question.
Okay.
In the loop, what if I want to run a loop with so if like I want to run a loop with some data in one data set and then other data in another data set, how would I incorporate that in the loop? Or would I just write 2 loops?
You could write 2 loops. You can write a loop with one loop with an if statement that says like if data 1 do this, if data 2 do this. But if you have 2 different data sets, I'd probably just use 2 different loops.
Okay, thanks.
If you have like data from 2015 and data from 2016, you could just smash them together and just write one loop. You don't have to keep the data sets separate too. You can combine them. Okay. So typical program or more low-level programming languages like C++. When I say low level, I mean like it's hard to explain, but R is built on top of C++, so it's a higher level programming language. So the lower level you go, like C++ is not vectorized, where we can just say like X times 5 and it'll multiply each element in X by 5. In C++, you have to write a loop to do each one of these things. So because of that, loops in R are extremely slow, or relatively slow, I should say. So you want to try to vectorize things as much as possible. Meaning if you have a variable X and you want to multiply by 5, don't write a loop to do it. Just do X times 5, right? That's a really simple example, but I see a lot of times people will write loops when they don't have to write loops, or make the loops way more complicated than they have to. So one thing is this function called if else. So what if else does is it takes your for loop and it takes your if statement and makes it into one. So this is a super powerful function. So for example, if I say I have roster, right? let's say height in inches. I'm going to plot table. So this is what the distribution of height in inches look like. Let's say if you're taller than 79 inches, you're tall. If you're not, then you're short, right? So what I'll say is if else roster height inches greater than 79, I'll say tall, otherwise short. So what this is doing is essentially writing a for loop. So if I run this, it gives me that. If I write a for loop for I in 1 to n row of roster, that's going to be 1 to 23. If it's going to be tall, else short. I have to add print here. So this is another example of when you need print and when you don't need print. We'll do print first, and I'll show you. Okay. So here's our if else, here's our baseline, and here's our for loop. It's going to do the same exact thing. So an if else is essentially taking this for loop and smushing it down to like super concise, super optimized code. So if else can run like this for loop over like 20 million observations in like half a second, whereas the for loop will have to go through each individual element and it takes a long time. So when you can use vectorization with an if else or some other thing, then you should definitely try to take advantage of that. So I mentioned the whole print thing. When I said print, it prints to the console. If I don't do print, what it's doing is it's just saying like, okay, string is tall, and then it just doesn't do anything. So if I run this for loop, nothing happens. So it just kind of got like shot out into the ether and then didn't end up in my console because I didn't tell it where to go. So typically if you're highlighting something like this, it will print. But if I run this just as like code, it won't work. So here's some examples of if else stuff. So for example, I say, if the first letter is equal to B, I'm going to put a 1. And now I'm going to nest the if else. So if it's not equal to B, I'm going to launch it into a second conditional statement. So if it's not equal to B, meaning it's Alex or Adam, I say if the last letter is equal to M, so nchar is the number of characters in the string. If that's equal to M, meaning the last character is equal to M, put a 2, otherwise put a 0. So 0 meaning Alex, 1 meaning Brian, 1 meaning Brad, and then 2 meaning Adam.
It just gives you that output, but if you want to make it a separate column, you'd have to assign it to something, right?
Right. So if I have names, right? If this is a data frame, let's say name. So it looks like this. If I wanted to do that same if else, so this is like names, $, value, and now names will look like this. Oh, that's supposed to be names, $name. It's connected in a way. I'll go through if statements, loops, strings. Ready to move on to functions? Okay. So R has all these built-in functions for you. You could call mean, you could do t-stat, you could do correlation, you could do linear model, right? Like I would not want to code my own regression code each time I need to run that. So having LM is really, really helpful. But sometimes you do need to create your own function. And the way to do this is there's a function command. So let me grab this guy. And he's going to be my custom mean function. So pretty much I'm going to pass some sort of vector x. I'm going to take the sum of x, make it the numerator. And then I'm going to take the length of x and make that the denominator. And then I'm just going to return the mean. So now I have in my environment a function called custom mean, and I can start to pass things to this. So custom mean 1, 2, 3 gives me the average. If I ask it for the average of 1 to 20, it'll give me the average. So it's working exactly how we would want it to, right? But now let's say I have a function or a vector that looks like this. I have missing data. Somebody didn't report their income, right? If I run this, well, now it's an NA value because when I passed it here, it tried to take the sum and it doesn't know what to do with this, right? It's a missing value, so it just returns NA. So now you have to kind of correct this. So I have a little thing here that says, okay, well, how would we do this? For the code, I wrote a little function here. So I'm just going to go through it quickly. But essentially, here's my second custom mean function. And what this is going to say is, okay, now it's going to take 2 arguments. It's going to take my vector. So if everything is still cool, it's just going to take the mean. But the next one is, how should I handle NA values? And that's going to be a string. The default thing is going to be worn. So for example, if I do, let me just run this. If I do custom mean 1, 2, 3, it's going to yell at me. It says, dude, you have to use an argument of ignore, 0, or random. So I have to pick one of these things. So I have to say handle NA. And I have to pick one, ignore, 0, or random. So if I pick ignore, it's going to enter in here. It's going to say, if handle NA equals ignore, I'm going to remove the NA values. So is.NA tests each individual element and says whether or not it's missing. And if it's missing, I want to negate that, right? I don't want to keep those. So I'm removing them. So for example, 1, 2, 3, NA is.NA. So this guy is the only one that's true. And I want to remove him, right? I want to get rid of that guy. So now if I do this, this is essentially what I'm doing. Keeping only 1, 2, and 3. So now if NA is ignore, I'm just going to ignore the NAs. So if I run this one, it's going to give me 2 as the average. So it yelled at me before, so I need to use ignore, 0, or random. So let's do 0. Okay, so if handle NA is equal to 0, it's going to say, is it equal to ignore? No. Skip all of this, go here. And it's going to say handle NA equals 0. That's true. It's going to enter it into right here. And it's going to say the ones that are missing, replace it with 0. So this is crazy. Like you would never replace missing data with 0, but for the demonstration, we want to, right? Maybe we have some sort of theory why this would be the case. So if we replace it with 0, that shouldn't be the case. Oh, I don't have NA. This one works, and this one's slightly lower because we included a 0 into our data set. And then finally, the last one, I was just trying to think of a third option. Otherwise, if it's equal to warn, it'll yell at me. So that's the default. So the default is that it will yell at me. But if there is no NA, it'll calculate the average. Or it should calculate the average. Not sure why it's not calculating the average. Oh, because I tell it that if I don't tell it what to do, it'll automatically return NA. It's going to force me to say if I want 0 or random. Or ignore. And then random, I think, picks a random number. I just put an NA. So each time I take the average, it's going to be different. Which, again, insane. You would never do this. But you could if you wanted to. You have the power.
So Alex, what would you recommend for missing data?
Oh, that's such a big question. I mean, some people would say impute. Some people would say use some sort of matrix completion. Some people would say if you have data that's missing completely at random, you can just drop it. But there's all sorts of different categories of missing, right? It's missing completely at random, missing at random, missing not at random. I think there's 4, but what I recommend, it's so case by case. I don't really have a good answer. So yeah. And then I also wrote something here, but I think we covered it yesterday, about using equals inside of functions like this versus using the arrow. How this is going to get treated differently than if I put an arrow. So there's a little bit of an example, a little simulation here, but we already went over it. So we have like 45 minutes left. This actually went a lot quicker than I thought it was going to. So we can do the homework together and kind of like go through it and spend less time tomorrow going over it. Or if you guys are gassed and want to be done, then feel free to leave. But I guess what I'm saying is you guys can go if you want, but I'm going to stick around and work on the homework if people want to. So let me stop recording.